Hey everyone, welcome back to this AI-3026 Developing AI Agents in Azure course, where this specific module covers how to develop an AI agent using Semantic Kernel SDK. My name is Peter de Tender. I'm a Microsoft technical trainer here at Microsoft for almost 6 years now. My Azure background has always been architecture and DevOps, but I gradually shifted more to app modernization and, no surprise, AI and Copilot solutions for the last 18 months. This module is one of the 5 modules in this course. You can choose to go through all modules or only a few, depending on your needed skills and where you are in your developing AI agents journey. This specific module builds on the concepts from the developing AI agent that we discussed before. It has a focus on positioning and exploring the integration of Semantic Kernel SDK. Are you ready? I would say let's go. As you know, in meantime, an AI agent is a program that uses generative AI to interpret data, make decisions, and perform tasks on behalf of users or other applications. AI agents rely on large language models to perform their tasks. Unlike conventional programs, AI agents can function autonomously, handling complex workflows and automating processes without requiring continuous human oversight. AI agents can be developed using many different tools and platforms, including our own Microsoft Semantic Kernel SDK. Semantic Kernel is an open-source SDK that enables developers to easily integrate the latest AI models into your applications. Now, part of that SDK includes the Semantic Kernel Agent framework, which allows developers to quickly create functional agents that can use natural language processing to complete tasks. The Semantic Kernel offers different components that can be used individually or combined. The first component is an AI service connector, which are used to connect the code to AI services, coming in from different providers using a common interface. Supported services include chat completion, text generation, and even more. Next, we have memory connectors, which expose vector stores from other providers using a common interface. Another component is functions and plugins. Think of them as containers, but not the Docker ones, for functions that are registered within the kernel. Once registered, functions can be invoked by the AI or through a prompt template. And that's the other component here, prompt templates. These are being used to combine instructions, user input, and function outputs into reusable format. Prompt templates allow AI models to execute predefined steps dynamically. And then last, we also have filters. Filters allow custom actions to be performed before, maybe after a function or a prompt is getting invoked. When registered, function filters act as outer layers and prompt filters as inner layers. Next, Semantic Kernel, as mentioned before, also offers a specific agent framework. The agent framework within Semantic Kernel helps streamline the creation of agents and enables multi-agent collaboration in conversation while integrating human input. The framework supports different types of agents, including Chat Completion Agent, OpenAI Assistant Agent, and Azure AI Agent. Obviously, no surprise, we will only focus on the Azure AI Agent within the framework as part of this module and course overall. Now, if after the previous explanations and motivations on Semantic Kernel are maybe not 100% clear yet, meaning you still have questions like, for example, this one: why using Semantic Kernel with Azure AI Agent Service? Let me summarize it. In short, Azure AI Agent Service provides that comprehensive platform for agent development. To augment the capabilities of your AI agents, Semantic Kernel allows you to extend on all characteristics you might already know from developing Azure AI Foundry-based applications. But now you're going to reuse all that skill and knowledge that you gained for building AI agents. Semantic Kernel provides a consistent code base, allowing developers like yourself to build solutions that really leverage the strengths of different kinds of agents. And then last, but I will cover more on this in another module, thanks to Semantic Kernel, you can develop AI agents acting like multi-agent solutions. Azure AI Agent is a specialized agent within the Semantic Kernel framework, specifically designed to provide advanced conversational capabilities with seamless tool integration. It automates tool calling, eliminating the need for manual parsing and invocation. The agent also securely manages conversation history using threads, reducing the overhead of maintaining state. The Azure AI Agent class supports many built-in tools, including file retrieval, code execution, and data interaction by using, for example, Bing, Azure AI Search, Azure Functions, OpenAPI, as we already discussed before. An Azure AI Agent object encapsulates all the core capabilities you typically use the kernel for, like function execution, planning, and memory access. This object acts as a self-contained agent runtime. Azure AI Agent is a specialized agent within the Semantic Kernel framework, designed to provide advanced conversational capabilities with seamless tool integration. It automates tool calling, eliminating the need for manual parsing and invocation. The agent also securely manages conversation history using threads, reducing the overhead of maintaining state. The Azure AI Agent class supports many built-in tools, including file retrieval, code execution, and data interaction using Bing, Azure AI Search, Azure Functions, and OpenAPI, as we already discussed earlier. An Azure AI Agent object encapsulates all the core capabilities you typically use the kernel for, like function execution, planning, and memory access. This object acts as a self-contained agent runtime. Now, to use an Azure AI agent, you would start with creating an Azure AI Foundry project. From there, you would add the project connection string to your Semantic Kernel application code, followed by creating an Azure AI Agent settings object. Next to that, creating the Azure AI Agent client, creating an agent definition on the agent service provided by the client, and then last, creating an agent based on that definition. Now, you might think that the previous structure and flow would allow you to build really smart, powerful, and useful AI agents. But wait a minute, there's even more. In Semantic Kernel, plugins allow our AI agent to use existing APIs to perform tasks it could not do on its own. Plugins work through function calling, allowing AI to request and use specific functions. Semantic Kernel routes the request to the appropriate function in your codebase and returns the results back to the LLM, so the LLM, or the large language model, can generate a final response. To enable automatic orchestration with function calling, plugins also need to provide details that describe how they behave. The function's input, output, and side effects should be described in a way that the AI can understand, otherwise the AI agent will not correctly call the function. Using plugins with Azure AI Agent is basically a three-step process. It all starts with defining your plugin. Now, what this means is you can create a plugin by defining a class and annotating its methods with the kernel function decorator. The decorator lets Semantic Kernel know that this function can be called by AI or referenced in a prompt. The kernel function decorator also supports a description attribute to help the AI agent understanding how to use the function. From there, you're going to add the plugin to your agent. Once you define your plugin, you can add it to Azure AI Agent by creating a new instance of the plugin and adding it to the agent's plugin collection. And then from there, you're going to invoke the plugin function. You can invoke your plugin's function by using prompts on your agent message thread. For example, if you have a plugin function called getTasks, your prompt to the agent might be, "What tasks do I have?" By following these steps, you can extend your Azure AI agent with plugins, allowing it to interact with other APIs and perform more advanced tasks. This makes your AI more powerful and capable of handling real-world applications in a super efficient way. Now, if you have been following me here in my AI agent development journey, you know that I not only like to talk through the material and explaining the core concepts, but I'm always excited when we get closer to the end of a material, since it means I can switch back to my demo environment and show you how to make this happen. So in this next demo, I will use Azure AI Agent Service together with Semantic Kernel to create an AI agent that creates an expense claim email. It might be an example that you could actually almost use as is within your own organization. So with the whole Azure AI Foundry project setup out of the way and already importing my sample code from my demo, again, assuming that you might be following along, remember you can grab this sample code from our Learn GitHub repo, where this time I'm inside our module number 4, where we're gonna have some fun with Semantic Kernel. As always, before actually doing something useful with the code, we need to install some libraries. So I'm gonna run a little snippet of code, triggering Python because that's the development language we're using, triggering a virtual environment called LabEnv, and within activating the environment, and then running our different packages using pip, installing Python environment, Azure Identity, and Semantic Kernel. And once this is done, we can open up our Visual Studio Code. Now, depending a bit on if you've been following along, like in I would say the maybe traditional sequence of this class, you already know why I'm using PowerShell. If this is the first module that you're watching, you might go like, wait a minute, Peter, we are developers. Why should we develop code from within the Cloud Shell in Azure? Well, it's just for me to show how easy it is, how platform independent you could actually use this. Now, to help you a bit, I'm not going to explain code snippets. I'm going to copy paste code snippets in Cloud Shell, but I'm going to use my local VS Code to do that. Now, again, if you're new to all this, what you can do from here is opening up your Visual Studio Code, stripped down version, I have to say, from within your Cloud Shell. The way to do that is running code with a dot, and that's going to open up Cloud Shell, but then launching Visual Studio Code from within. Now, as always, we need to complete our environment setup, where we need to provide our project connection string and the deployment name. Then from there, we're going to move into our Semantic Kernel, and this is where I'm going to switch over to my VS Code. So I'm going to use my local VS Code environment to again just clarify the snippets of code a little bit, helping you understanding as a developer, like what is the code looking like. Knowing that this is just demo code, it might not be exactly what you're going to do in your production environment, although the code is actually 100% functional. So again, using some expense claim agent that we're building here, and we want the tool to send an email. I'm not going to explain each and every line of code, but I'm going to highlight some of the core references. It's also, again, if you downloaded the sample reference code from our GitHub repo, you're going to see those little reference points up here. So the starting point is importing the statements where we're going to load the necessary namespaces and the necessary libraries that we need to implement our agent. And that's what you find over here. So we're going to load Azure Identity, we're going to load Semantic Kernel agents, and we're going to load Semantic Kernel functions. From there, we're going to create a plugin, and that's the Semantic Kernel terminology, as hopefully you remember from the presentation. So what we need is creating a plugin for actual email functionality. I have this all the way down in my little Python snippet. I'm going to define a new class called email plugin. Technically, this is not really connecting to any email like Exchange Online or M365. It's just obviously simplifying the scenario, but you probably get the idea what's happening here. We're going to define the definition send email. We're going to use the subject, the body, and then I'm just going to show you on screen how this actually works. With all this out of the way, we also need to define our actual function. So what we need is some configuration settings, and that's what you find over here. So we're going to load our environment, and in there we're going to grab our Azure AI Agent settings, and we also need to find a way to actually connect to the AI Foundry project. This is the exact same code that we used in the two previous demos. So we're going to create a connection using Azure Credential. And from there, we're going to create a new Azure AI Agent client. We're going to define the baseline AI agent settings, which means in this case, we have a definition for our expense agent using the model, defining a name, and we're going to provide some instructions where, again, if you've been using traditional Azure AI Foundry development for AI service integration, this is what before I would say we would call the system message, where now within our Azure AI Agent context, we call this instructions, where you define an explanation. Hey, my dear agent, this is what I want you to do. And then we're almost done, where I would say the core of this module is focusing on that semantic kernel agent. So we have the project integration in place. We have our expense agent definition in place, and we're going to create our agent that we call expenses agent using the Azure AI Agent method over here, the client, the definition, and calling the plugin. And then, as you probably already know, our AI agent also needs a thread. That's what we specify over here, where we're going to create a new Azure AI Agent thread, some try except, so like a try catch scenario to make sure if there is a problem with the code that it's actually not crashing, not breaking. And I would say that's pretty much it from here. I'm going to grab all this code because you already know I'm not running it from within my local machine. Again, would be totally fine, but it's just so cool to show you that you could run all this from within Cloud Shell as well. I'm going to override my starting snippet of code. I'm going to save it, Control S. I'm going to step out of VS Code, Control Q. And from here, the only thing I need to do is actually running my code. So I'm going to run Python, pointing to my semantic little kernel agent. And it's running, as you know from the presentation, in an self-service-alike model. So what it's doing here is connecting to the data backend. It's creating a sample email, sending it to my expense tool. There is a subject message. I have my itemized expense information. It's running some nice calculations. You can obviously validate if all this is correct. And then the core of what we want the agent to do is this message here. Your expense claim for the provided items, like me uploading my expense receipts, has been sent to your expense backend, and the total submitted amount is 215 something US dollar. That's really all it takes to build, create, develop your own standalone Semantic Kernel-based Azure AI agent. So with that, let's go back to the presentation for the last couple of words before jumping to the next module. In this module, you learned how the Semantic Kernel agent framework enables developers to build AI agents. You learned about the components of the Semantic Kernel SDK and the core concepts of that agent framework. You also learned how to create plugin functions to extend your agent's capabilities. By applying all these concepts and skills, you can leverage the Semantic Kernel agent framework to create dynamic, adaptable AI solutions that really enhance user interactions and automate complex tasks. I really start seeing the potential of these Azure AI Agent Services for developing AI agents. Thanks to Semantic Kernel, our agent becomes even more useful. But wait a minute, there's one last scenario we need to look into: orchestrating a multi-agent solution using Semantic Kernel SDK again. So I would say get that little break, refill coffee or any other drink, but don't run too far away, as I'm going to jump right in. Thank you for being here with me, and I'll see you again soon.